what some of the primary learnings you had personally were during your PhD. You did a PhD in cognitive neuroscience at Berkeley, and that's no small feat. Anyone who's done a PhD knows that. I haven't done one, but I've heard. So I'm curious what some of the biggest insights were for you individually when completing that, and also if you could maybe to lead in, just give a little bit more context for folks listening on what it was that you were researching and that you focused your PhD on.
Happy to, yes. So I specialized in a concept and a phenomenon known as cognitive neuroplasticity. Now, neuroplasticity is this phenomenon that the brain changes and adapts according to environmental conditions and training. So our brain is not static, it's dynamic. It changes and it adapts, just like in muscles, right? You go to the gym and you can pump some iron and you can get a bigger, potentially, if I only worked out, let's say, for example, my right bicep, like that would grow bigger and stronger, and then my left one would not. You can actually go in and train almost like precision medicine. You can train accordingly. And the brain also adapts, trains, and is plastic, neuroplasticity. Now, cognitive neuroplasticity is really zooming in on cognitive performance as it relates to neuroplasticity. So we're talking about attention, we're talking about memory, we're talking about information processing speed, we're talking about general fluid intelligence. And the big focus for my research was and continues to be cognitive training. So what can we do non-invasively? Because I used to do more pharma research, but what can we do without drugs and without other invasive methodologies? What can we train people to do internally and naturally? Maybe strategies, maybe techniques, maybe going of mindset changes to actually improve, measurably improve cognitive performance, but also literally change the brain and how the brain is structured. What can we do in a short amount of time with people that are already super smart and already super healthy? So not necessarily focusing in on traumatically brain injured populations or populations that are clinical. That was my area of focus. Now, I'll tell you about one thing that is, I think, the most important thing that I learned and gained, like an insight gained from this research and this work, and that is that it's possible. Because I can tell you when I was first starting out, it didn't seem possible. I actually had a faculty member from Stanford kind of not laugh in my face, but definitely chuckle pretty hard during a meeting when I was presenting some of my hypotheses. I'm like, all right, this is going to be this is the layout. This is what I want to do for the next couple of years. He was just like, you can't take these you can't take Stanford students that are like, it's like they're 21 years old. They're at the peak of their cognitive. They're like the cream of the crop. Their brains are perfect. They're some of the smartest people in the entire world, and they're young and super healthy. You can't take that brain and then just arbitrarily, like a sci-fi movie, like decide to just like, oh yeah, we're going to make them even smarter. Like, it's like, no, it's not going to happen. Not true. Apparently it can happen. And we did it in 7 weeks, still non-invasively. No drugs involved. We did it in 7 weeks. So that was the big success story. That was the huge insight, is that it's possible to improve cognitive performance in as little as 7 weeks with a healthy, happy human brain that's already at its peak. And you can do it non-invasively. You can do it without a bunch of fancy stuff. You can do it literally with basic things like meditation, forcing yourself to sit down and focus when it's otherwise not required. Forcing you to sit down and focus for long durations of time in order to train your ability to focus in the future.